All right, so quick announcement, independent of this class. We need current students to log into MyGCC and take the 5-minute diagnostic. This is it's a diagnostic to figure out how much technical skill the students at GCC have. And it's totally fine if you are a whiz at computers, and it is totally fine if you don't know how to turn them on, and anything in between. We're just trying to figure out where our students are in terms of technical ability. Yeah, so that's okay. So this is phase 2, actually. It's a new one, different from the one that we had last semester. It is completely voluntary, but in order to grease the wheels a little bit, if you take this 5-minute diagnostic, you will be entered into a raffle to win 2 pizzas. So check it out. I'm pretty sure that you guys got an email about this, but I just wanted to point to it as well. It's very easy to find. I think that this PDF was emailed to you recently. You log in. If you don't know how to log in, ask me. And then inside of the main screen, in one of these menus here is just something called the Tech Proficiency Exam. All right. The more data we get, the better we will be able to support the students here at GCC in terms of their technical needs. All right. Okay, so let's jump back here. We're on page 58. Page 58 just begins with a reminder about a heads up about dealing with addition, subtraction, multiplication, and division with not just positive numbers, but negative numbers as well. Remember, we had said we were keeping the negatives away from our algebra for a while, but time is passing, and if you need to brush up on the negatives, you need to do that sooner rather than later. And there's lots of suggestions here on how to do that. And one more thing, we don't use calculators very much this semester, but there is a period of our semester coming up very soon where we will be using the calculator. So make sure that, that you get one if you are able to get one. So let's move on to the next page, which is 59. And we'll start at the top with the objective. Can we go to Chris? Thank you. Henry? Okay, so 9.6 equals t plus 2.08. We're trying to solve this equation for t. Lauren? Okay, so I'm going to say we're going to subtract 2.08 from. Lauren said 9.6, which is correct, but I'm going to say it slightly differently. I'm going to say subtract it from both sides. How did Lauren know that was the right thing to do to solve this equation for t?
That's how you get
Yeah.
Subtract 208 from 208. 208 disappears, but then to balance the equation, to make it mathematically correct, subtract 8 as well. You have to subtract both sides in order to have the equation balance.
Do we buy it? Right. Whatever you do to one side, you must do to the other. It's like one of the golden rules of algebra. And why is it a subtract 2.8 and not like a multiply by 2.08? Somebody we haven't heard from yet? Yes, Amy. Do the opposite of the operation that's already there. Somebody took our poor little t here and added 2.08 to it. Well, we need to undo that. We need to do the opposite, subtract 2.08. Fair? Okay, part B, Z. Could you read part B, please? Okay, so I'm just going to copy that equation again. 9.6 equals t plus 2.08. And then we're going to subtract 2.08 from both sides. I'm going to put it right underneath on both sides. Subtract 2.08. Subtract 2.08. And then I'll put a little line that says I'm about to do the work here. And let's do the easy part first. The easy part is the right-hand side. As Sadie points out, what happens to the 2.08s? They're gone, right? They cancel. So the right-hand side is simply, so there's a 0 from the 2.08s, but what's still there on the right-hand side is the t, which is great. So it's a t equals. Now we got to do 9.6 minus 2.08. I'm going to strongly suggest that you not do that arithmetic on in the middle of this algebra problem, but rather do it off on the side. So here's my arithmetic off on the side. We'll even put it in a different color. 9.6 minus 2.08. No calculators, but take a moment to do this calculation, and I strongly suggest you shove it over there on the side. Who's got the answer here? Chris. Chris says 7.68. Sadie says 7.52. Amy agrees. Other votes? Yeah. 7.52. Chris, 6.68 isn't looking as good anymore. All right, so since math is a democracy, let's go with the majority here. 7 point, that was a little joke. Right? Okay, so 7 point, what do we say, 52? Okay, yeah, 7.52. And again, this is one of those prerequisite things. We are not spending any time talking about the arithmetic of decimals, but you got to be able to do it in order to do algebra problems. So 7.52 is great. We'll bring that right back over here. And again, highlighting arithmetic stuff should go off on the side. It can really easily clutter up the algebra problem. So that's it. I'll circle it. This is our answer. Questions on this one? Okay, moving down to part C. Can we go to Lauren? Okay, so how do we know whether or not we got the darn thing right? Well, we started off with an equation right at the very beginning, 9.6 equals t plus 2.08. We think that the answer, the solution, is 7.52. What that means is that in the original equation, if instead of t we put 7.52, we would have a true equation. So I'm going to write that equation from the top, the 9.6 equals, put it here in black, 9.6 equals, it says t plus 2.08, but instead of t, what do we think t is? 7.52. Plus, and then copying the rest of the equation from up above, 2.08. So I'm just going to highlight. It used to say t, and we figured out that t is actually 7.52, and so instead of the t, we put 7.52. We see that that top equation is just copied down below, but instead of t, it's 7.52. So if that numeric equation is true, then we got it right. If that equation is false, then we got it wrong. Okay, so let's just double check. So I'm going to do the check over here. So if I do, whoops, if I do 7.52 and I add 2.08, so don't cheat, but actually do the arithmetic, like do this check, even if it seems easy, just do it. And if you add them up, what do we get? Yeah. In fact, probably you wrote 9.60 if you actually did the arithmetic, and that's the same as 9.6. And so it worked. And then we'll go to Morgan for this it may part. Okay, things will get tougher, but I think it's a great habit to be in is to just check. So one quick thing here before we move on to the next page, this notation business that I'm talking about. I'm just going to write down two quick equations. We're not going to do all the steps that we did up above. But for example, if I said 3x is equal to 7, and I wanted to figure out what x is, what would I do to both sides? Right now it's 3 times x, so we would divide by 3. So the way that we write division is something like this. You put like the big fraction line, and you say this is how we divide both sides by 3. I just want to point out how it looks, and that it's just a little bit different than how it, oops, and how it looked up here. Undo. How it looked up here was we wrote here in red, subtract 2.08 from both sides, and then we put this big line that says we're about to do the calculation. Well, it looks just a little bit different here. Here the line indicates division, right? Divide both sides by 3. I'll make up one more problem here. What if we had something like this? R divided by 4 is equal to 6. What's the opposite of dividing by 4? Is multiplying by 4. So I'm going to copy the equation again. I'd like to copy it again just so we can see where it came from. And then I'm going to say here in blue, we're going to multiply both sides by 4. So I'm going to do 4 times this side, and I'll even put it in here, 4 times this side. So this is how we write multiply both sides by a number. Questions on the kind of different ways to write, add something to both sides, subtract from both sides, multiply or divide something on both sides. Okay, on the next page, there's some notes for later reference. Here's another example worked out. It's quite similar to the one that we just did. Different numbers, but the same idea. Just highlighting the word solution here. We've already used this word today, but the answer that you get at the end, the value of the variable that you think is the winner, is called the solution. Okay, so we're going to move on to the classwork, which is here in the middle of page 61. So we will come back together in a little bit to talk about one little detail in one of these classwork problems, but start in the middle of 61 and see how far you can get. Work with each other, raise a flag if I can help. All right, so we're talking about this problem where Bob goes for a 90-minute drive every Friday night and uses his cruise control so that he is driving at a steady speed during the entire trip. And the first part has to do with defining variables. Define variables and write an equation for the distance in miles that Bob drives in terms of the speed that he is driving. Okay, so we've got 2 variables we're trying to define. It tells you what those 2 variables are supposed to be. One of them is distance. Great. Let D equal distance, and it even gives you the unit word there, distance in miles. Okay? And then the other part says in terms of the speed that he is driving. Great. Let S equal the speed. But we always have to have not just the quantity word, but also the unit word. When you are driving, what is a very natural unit for your speed? Is miles per hour. Okay, so it feels like those are 2 good units to have up there. We've got distance in miles, speed in miles per hour. Here's the little twist in this problem. The time that this drive takes is 90 minutes. There's something kind of funny about the way I gave you that information. What's funny about it? Miles per hour. But I'm telling you the time in minutes. And they just don't go together. So you can't have an equation with 90 in it. We got to change that 90. That 90 is not very useful in its current form. Instead of 90 minutes, I need to be thinking about it in terms of hours. So I'll just write over here, 90 minutes is equal to how many hours? 1.5, 1.5. So it's this little conversion, and it's a twist. And maybe this is the first time we're seeing the twist, but I need us to struggle a little bit and maybe recognize, oh, I didn't see the twist the first time. But maybe the second time, you'll recognize, you still won't get it 100%, but you'll recognize, wait a minute, I got to think about making sure the units match up. And then maybe it gets easier to recognize and not fall for this trap. Okay, so now that we've got that, I think we should be able to get our equation here. So it says distance and speed. Which one is the one that's by itself? It says distance in terms of speed, which distance is by itself. So the distance is 1.5 hours times the speed, 1.5 times S. Okay. All right, so now we've got a good starting point for this problem. Keep working through. We'll come back together in just a few minutes, but see how far you guys can get on this one. If you finish, move to the next page, and then I'll call you back. Okay, so everybody look up here real quick. So you plugged in, hopefully you got S equals 60. I just want to talk about parts E and F together as a group. Okay, the solution to the new equation is, and it's just S equals 60. That's the solution. The only reason I'm pointing to this problem here together is that we want to be really clear about what the word solution means. The solution is the answer, but it is not just a number, it's an equation. It's a variable equals a number. The solution here isn't 60. 60 is kind of meaningless floating around on its own. We ground it by saying S equals 60. The speed is 60. And essentially that's the sentence that I'm asking for in part F. So it's very easy to write lots and lots of stuff, and you're welcome to write lots and lots of stuff, but if you want to keep it short and sweet, I will give you what is like the minimum acceptable full credit answer for the sentence. You don't need to go into like a long diatribe about Bob and what he's driving along and what he's seeing in the 90 minutes, any of that. You just need to say something as simple as Bob's speed is 60 miles per hour. That's all I'm looking for. There are other full credit answers, but if you just want it short and sweet, that's all I'm looking for. You don't need to tell me how long he's driving. You don't need to tell me how far he's driving. You don't need to tell me really anything about how you solved the problem. You just need to tell me, okay, the person here is Bob, and his speed is 60. Don't forget the units, miles per hour. And the last thing to say about this one, it's going to be kind of hard for me to go back and forth on this, but I'm going to make it so you really can't read what's up here. But I want to compare part E in this problem to a part on the previous page. So can you guys have both? It's on the same piece of paper, or is it different? What's the previous page? Down here in number 3 in this previous page, did you guys have something like, here, I'll make it bigger just for a second. But in number 3, part C. Let's see, so what's the answer to number 3? Is that 146? Yep, okay, so if the equation 146 minus 56 equals 90, is that what you guys have in the blank? Yes? Yes, okay. So I just want to compare that thing, 146 minus 56 equals 90, to this thing, S equals 60. They look similar in that they're both equations and they're both near the end of the problem, but they're really different things. S equals 60 isn't so much an equation per se, but it's our solution. It's our answer, all right? The solution to that original problem is S equals 60. But on the previous page, we are saying to check that our solution is correct, we are hoping that this numeric equation is true. And I want to highlight the word number. I'll literally highlight it here. Numeric has the word number as its base. If you see numeric equation, it means that everything in the equation is numbers. Everything in the equation is numbers, right? There's no letters in that equation. So do you see the difference between this and S equals 60? Kind of look similar, but they behave very differently. Okay, so you guys can continue on, see how far you can get. There's lots and lots of problems to do here and not enough time to finish them, but see how far you go.